G'day and welcome aboard, everybody. Thank you very much for joining us today. And we're back in the room with the team from Napier there. Hayden and Doug will introduce as we go along. And we're focusing today on sustainability, not at the expense of performance, talking about advanced concrete admixtures. And very quickly, I'll just bring up the slide deck and away we go. So as I say, Hayden and Doug, who some of you will have met before, and will introduce themselves as we go along. And there's a questions and comments field in the bottom of your toolbar. The agenda today relates to what are the impacts of the various SCMs in current use. You might well ask what on earth an SCM is, and how can we optimise the performance of the resulting concrete? Can we preserve the surface integrity and the durability of that concrete? So as I say, questions and comments at any time using the Q&A button at the bottom. And if you'd like to start the ball rolling, we'd like to hear from you in the comments. What concrete additives do you currently use? So, Hayden, do you want to take us away with the first topic?
Thanks, Brendo, and good morning all. Good evening if anyone else is on that side of the globe. But I appreciate everyone coming on. It's such a good topic out there at the moment, and it's good to be part of it. So yeah, Hayden Prestige, based out of Napier, working across Australia and New Zealand in the ready-mix concrete space for Markham, been about 10 years or so. But really wanted to jump into, obviously there's a very noticeable drive in lowering carbon footprint of concrete production, and it's gaining a lot of momentum. Obviously there's a lot of authorities, governments, a lot of projects driving for a large reduction in cement, and it's all pushing momentum and energy into looking at cement replacements and these supplementary cementitious materials, and that's a SCM for those unaware of the acronym. So we do use a few acronyms. That's an industry one, but you'll be aware of that. So that what is an SCM? It's basically anything that it's a binder to try and move away from cement. So it's replace cement with some things. Slag is a common one. Blast furnace slag. There's fly ash, that comes out of there's production of coal, etc. Or these, people are looking at calcined clays, different products that are coming that can act and react and cause a replacement of concrete, cement. And then you can also move into areas to reduce the GWP. Here's another acronym. Global warming potential is another one to look at, which is in this topic as well. But then there's people looking at crushed rock, different manufactured sands, etc., to try and pull back and reduce the carbon impact of concrete. So just interesting. I think about there's about 4 billion tons of cement produced annually globally, and every ton that's produced is about 0.9 of a ton, so almost point of carbon emissions produced. So that's a lot globally, and that equates to about 8% of total emissions in the world. So it is a topic. It is a topic we need to be behind and get them behind, and that's what this is for. We can get concrete. There's still a lot of people that say, hang on, just take me back to the good old GP, the good old cement days. But we can get concrete to that point, and this is what this discussion's about, is how to get it there. Using SCMs does have a challenge, and no doubt you'll all have challenges in your minds, right from designing through to production of concrete, through to placing and finishing. So let's have a bit of a look at some of those. Brendan, if you want to jump to the next slide. So long and short of it is, all these cement replacements do act and behave different in the concrete, and it's not that a lot of us wouldn't be aware of how that can react, and the times, the reactivity, what's needed to make the strength go off, etc., is all different to what we lived and breathed in the concrete industry, and so it might be struggling with some of the traditional approaches out there. And then, like I was saying, there's some benchmarks and big goal setting done by corporates and authorities on cement replacement and lowering carbon. People pushing the 70-80% replacement, which is very interesting and good. A lot of research and development in there, but there's some of the challenges that we're seeing. We'll just run through them quickly. Powdered sort of replacements that, even from a safety point of view, there's a lot of handling, and obviously there's a micro nano-sized powders that are harmful, and then quality control of adding those. How do we get them into the batch right, etc., and then the demand on the mix, or the demand on the water, things like that. Strength development is notably a big topic in the industry. How do we get our early strengths, if we can't use our cements, etc. Piling is an interesting one, where you get things like moisture loss, and you get a lack of cohesion in a mix that can result in real poor quality piling work. There's a lot of challenges through to the placing and finishing of concrete, and that's largely probably because we haven't done training and effective intelligent training through that on how to treat a different mix in a different way. Especially with the SCMs, you get different like bleed, and you can get different workability, different how it closes at the surface, how its porosities work, etc. Working time and workability is pretty important, and that is different to normal GP concrete. It's what we're seeing as issues. People that are familiar with good workable concrete from cement is being challenged with these replacements. Bleed's important, like I was saying before, how they react, how their demand on water, and they might get quite a different process there, and you get like secondary bleed or delayed bleed type work that comes up, and that causes durability issues long term. So spray concrete's another one. No doubt you'll be familiar with some of these, but I'd love any questions on these or any other challenges that you see. Just pop them down in the chat, and we'll get to them at the end as well. But that's some of the things we see. When you're pumping, is it flowable? Is the mix right? How's that reacting with our pump pressures? Is it causing rebound? Is it closing off? Those sort of things. Is it setting right to stick to the wall? So that's some of the things we see. And really, all that goes into the durability and integrity of the concrete being challenged long term. But I don't know if Doug, you got any comments on that?
No, that's good. It's a good outline. Thanks. If we could go to the next slide there, Brendan. Thanks for joining, everyone. I'm Doug Hamlin, work in the research part of Markham. So looking at how we optimize these mixes, overcome some of these challenges, there's really two items I want to focus on of what Hayden's just gone over, and that is the early strength gain on these mixes being one of the bigger challenges, and then secondly the workability of these concretes. So there's really three ways that we can look at this. Either we say, hey, accept that it's a totally different material, it behaves differently, it finishes differently, closes up, everything, all those things. It's a completely different and new material, and we need to essentially retrain everybody on how to deal with these mixes. The second one is what we see already happening, is that yes, they are replacing 30% of the cementitious with, say, fly ash or slag, or it might be higher, whatever it is. But we're also increasing the GP cement to make sure we get that early age strength and workability in the concrete. And essentially, what we're doing there is that you're still using more cement than you need to. SCMs obviously have a lower and slower strength gain. So typically what you would see at 28 days on a GP standard concrete, you're seeing it around 56 days. And if you take that back upstream, in terms of getting onto slabs, that type of thing for construction workers to carry on, you're sort of looking from 1 day out to 2 to 3 days. So there is some delays there which need to be taken into account. And then the third option that we can look at is specialized admixtures. The hydrogel admixtures are the ones that we look at, we specialize in, and that is to get the concrete, these SCM concretes, behaving more like a GP concrete. So this is in terms of how they place on site, the workability. We've done a lot of concrete there where the workability is, it's pumping nice, it's placing nice. You're not getting that late bleed out of the concrete. It's more like a standard concrete in terms of that. Durability is another area. So the SCMs themselves, so especially slag concretes, has a higher durability anyway. We can take that and further increase that with the use of hydrogels. So you're getting the best in terms of protection there. The only issue, as I've mentioned, is that early strength gain isn't there. So while the end result is great, the logistics and the critical pathways in the construction are affected in terms of getting that, getting a construction program on track or keeping it on track. So yeah, that's really the options out there in the industry. Just touching back on that cement point again, what another side effect of that, so obviously increasing your GP and putting SCM in as well, is that you're hitting those early strengths well and good, but then when you get out to 56 days and plus, you're actually hitting well above what you need to in terms of your strength of the concrete. And most of you would say, or you might think that's a good thing. It's not necessarily, because engineers do have maximum strengths that they want structures to get to, so they don't want it being too strong, too brittle. They do need it to be in that sort of strength range for the engineering designs, the earthquake seismic designing, that type of thing. So yeah, something to bear in mind there. If we could go to the next slide and have a bit of a deeper dive into hydrogels and how they affect SCMs. Firstly, they are a liquid admixture, so they're much easier to dose on site and safer for the staff there. And being nil VOC, they're not giving off any solvent smells, that type of thing. This is also true when you're coming through to placing, that type of thing, so you're not getting anything abnormal there. And the safety, it's not a crystalline silica product, so it's a colloidal silica, which is fundamentally different and basically comes down to the shape of the particles. So there's no silicosis risk and that type of thing with these materials. The workability, as I've mentioned, so they're essentially a sphere in shape or circular, and that helps the rheology and workability within the mix. So the mix is essentially lubricated. So when you're placing and finishing, that type of thing, it's flowing. Pump pressures, you can lower pump pressures on like a standard pour like we've got in the photo there. Also for shotcrete, sprayed concrete, that type of thing, you can bring back that pressure, so there's less effect on the gear. Also, when you're screeding, raking concrete around, it's not stiff and sticky for the concrete. So when the end result is you get a more quality finish and quality concrete. It's all round the reinforcing steel where it needs to be. It's finishing off nice at the top. You're getting a good surface, and that workability is improved. And yeah, I've mentioned the durability is enhanced as well there, which is obviously a further sustainability benefit there. Hayden, do you want to touch on the surface challenges or with these mixes?
Yeah, sure. And just a reminder, keep firing questions in. We'll have a good session at the end just to go over specific points that you've all got, because that's always the best part of these sessions is when we discuss actual challenges that you're facing. So just pop them down there and we'll get into them soon. So yeah, surface durability. Well, durability and concrete integrity as a whole is very important. Obviously, there's a lot of modeling and a lot of history with GP concrete, and there is challenges, there's concerns, there's hesitations in the market of how long will my structure last? You know, I've got cement replacements. I'm looking at this geopolymer concrete. You know, we're really pulling back on cement, etc. What's the long-term outlook for my structure? If it's in the marine zone, or carbonation, those sort of things. Those sort of things are very valid hesitation. So, but one thing I just wanted to touch on is surface durability, and that's quite interesting. The structure, the concrete matrix itself should be pretty protected, but what you can find, because it reacts, because of these cement replacements, etc., react different with water. They let go, and some of the admixtures in there, etc. You can, as I touched on earlier, you can get those sort of delayed bleeds and different finishing things, and you might see different coloration, etc., on the surface. You've probably seen that in some of the mixes. That's all in this topic, and that can result in a lot less strength at the surface, and that's subject to wear. You get machinery running over it, you get traffic over it, and that's subject to wear. You think of a car park structure where you got turning on every corner, those sort of things. You'll notice wear quicker if it's not done right. So these are some of the things that need to be considered, and these are some of the things that we need to overcome, because otherwise, we can reduce cement, we can reduce carbon, but if we're building the structure again prematurely to what it should have been, we haven't really overcome anything in the industry. We've just used more cement again. So those are some of the things to think about. There's ways to increase that abrasion resistance, etc. And we're finding fluid silica is a good way of overcoming that. So just touch on there. So anything to add on that, Doug?
No, it's just actually there is, sorry. Just what you said about the durability of the matrix itself, that's typically with especially with blast furnace slag, you're not getting that is actually getting a better result than standard concrete. It's just that surface, and it has to do with, like you say, the way it finishes, and can sort of bleed differently, those sort of things. So yeah, if we wanted to wrap things up now, as we've gone over, we want to push for these low carbon mixes. They are here to stay, and it's good in terms of the sustainability of the concrete, reducing that global warming potential, and achieving that a more sustainable result overall. And we really want to be able to do that without having impact on the performance of the concrete. So in terms of GP concrete, we're getting that same workability, same placing performance, and then obviously long-term performance of the concrete as well. We want to achieve that, get that as close as possible as we can there. So yeah, the challenge we'd really like to leave with you today before we go into the questions here is there any need for performance of these low carbon concretes? That's whether it's durability, surface wear, placing, all those sort of things, to be compromised with the use of these supplementary cementitious materials in the concrete. We don't think so, and it's an area where we are committed to developing further, and getting these concretes closer to standard concretes. But obviously there's a few challenges that we've gone over that we need to take into account and think about. but yeah, the good news is we believe it can be done, and look forward to getting into your questions now.
That's
Thank you very much. Sorry, on Hayden.
no, that's good. There's already a couple of points in there, but just how does Markham reduce the rebound and spray concrete without compromising?
Yes, yep. Go ahead and
It's
give us that one.
It's interesting. So we do a lot with sort of underground construction, shotcrete, basements, those sort of projects, and it's really interesting. Or even you'll see the same even in line pumping or pumping vertically up up structures, etc. Essentially, what's happening is by the inclusion of colloidal silica hydrogel, like Doug was speaking about, uh, it lubricates the mix. In short, it provides we call it a hydrogel, and so it stays in the gel form, and it just helps the rheology, but it also helps it stay together. So it holds it together, and so it gets a quality concrete, but it lubricates it so it flows, pumps, and places better. So what that does as far as reducing rebound is you can wind back, and we've seen this numerous times, wind back the pressures on your pumps and your equipment. So you get an advantage there as well, which ultimately reduces things like rebound because you're not firing it at the wall as hard, but also the cohesion, holding it together and setting up that concrete. So hopefully that makes sense.
Very good. We had a couple of questions which came in before the session. Very much appreciate that. Anthony was asking about any product updates and experience with global warming potential, which I think you touched on before. Do you want to talk about EPDs, I guess?
Yeah, global warming potentials is very valid, and it should be looked at. A lot of concrete ready-mix producers have now got a lot of EPDs on their environmental product declarations on their mixes or their standard ones. I believe every product that goes into concrete should have EPDs as well, and that obviously dictates your global. Every product comes out with a number on it, so you can calculate your global warming potential, and it is a factor that's been looked at more globally, which is good, and it's actually a number that can be actually put into actual numbers, which is something we haven't really had before. So so there's a drive, obviously, from different projects or sustainable councils, etc., to reduce or get down to target levels. It's a way to calculate that now to make sure you're in that framework. So it's really good. But we believe it can be done, obviously, by pulling back on admixtures, cement, replacing it with these things and putting it in. So it's hopefully that makes sense on that one. Anything to add there, Dirk?
No, it's covered it well.
Anthony's also got a question on the waterproofing of old foundations and spalling repairs. I guess it's something that occasionally we involve admixtures in that kind of situation. I was thinking of that old wharf that Markham did many years ago.
Yes, yeah, that is an option there. Another area we get involved in is the sprays, so we can protect the original concrete, and then any repairs have an admixture in to protect them as well from ingress of contaminants, whether it's chlorides or protect from carbonation, that type of thing. But yeah, like you say, Brendan, it's slightly different to what we're going over today, but it'll be good to send a bit more detailed info out after this, I think.
That's good. Just a question from Carlos came in, as I say, before the session on corrosion, aspects of corrosion in post-tension concrete, most common tests to detect it. Did you want to just say a word on that? It bears on making the concrete last longer. I suppose it would relate to what you just mentioned about spray applied treatments.
Yeah, that is an area of concern, especially because once you get that corrosion happening on those tendons or on those strands, it's it's almost too late to. You can't do a traditional repair where you take out the rebar, weld it together, and go again. So it really does. I agree with you, Brendan. It highlights the need to protect the concrete itself as much as possible to stop those contaminants getting into the concrete, moisture getting into the concrete, so it can start that corrosion process. So yeah, that's really all we can do from our side. We're not so much into the testing area, but yeah, we're more about the preventative side of things.
Yeah, all I was thinking, I mean, corrosion pretty much contaminants or moisture and chlorides really, and if you can take those out of the equation, you're doing well. There's surface tests you can do on permeability, different tests like that, or take cores, know what your chloride profiles are at different depths. You're especially thinking around your depths of your tendons, and so you need to do that. But that's probably something you could monitor. But long and short of it is durability. Essentially, we think comes down to allowing how much allowance of moisture can get into the structure, and if you can take that out, if you can stop moisture moving and take that out of the equation, you're doing a good job to get that. But obviously, these all come in from these cement replacement examples, and if we're not getting things right, you are allowing different paths and contaminants and moisture to get into the concrete, and you can result in premature loss. So yeah, question there around how does the chloride silica hydrogel enhance durability? So yeah, probably touches on roughly what I was just saying, as the hydrogel essentially sets up in the porosity and blocks the porosity and to stop moisture migration, essentially, as it grows more calcium silicate hydrate and really densifies that concrete matrix and protects it against contaminants, acids, chlorides, those sort of things that get into the concrete.
Yeah, I was going to say that the cement efficiency of your cement has increased as well. So, in those early stages, you're getting more bang for your buck, if you like, out of the cement, and that creates a more lubricated, more creamy mix. And then obviously that hydrogel in the concrete helps it place nice. And then as Hayden's mentioned, the calcium silicate hydrate formation is accelerated or sped up. So and you're getting a more denser, less permeable concrete. So that's how it increases that durability there. See any other questions there, Brendan? Or?
Any other points that we wanted to? Here we are. Yep, thank you, Samson. That's much appreciated.
I'd be interested if there's any other specifics around sort of cement replacements or what people are finding and what people are trying to overcome. But we'll be doing a series of these anyway, so it'll be good to have everyone on board, and or we'll fire out an email as well. But after this, so come back with any specifics or something that might jump into your mind, and happy to chat it through from what we've seen.
Yeah, I was just going to say we'll definitely send up a follow-up email. Got a couple of links on there with some related information, and if anybody's got a project-specific question or a case-specific question, we'd be happy to have a look at that with you. Thank you very much to everybody that's joined, and appreciate the questions that have come in. Been really good.
That's good.
Thank you.
Thank you.
Very good. Thank you all.
Good. Yeah.
Markham, adding life to concrete.